Algorithms and artificial intelligence. Welcome everyone to another video in the series, What is AI? I'm your host, Professor Gary Locklear, and today we want to investigate the concept of algorithms. What do algorithms have to do with computer systems? And what do algorithms have to do with artificial intelligence? Those are great questions. So let's answer them in algorithms and AI. In order to understand how AI works, we really need to understand how computer systems work. Computers solve problems. And how do they solve problems? The answer is computers solve problems by following algorithms. So let's investigate what an algorithm is and how algorithms relate to artificial intelligence. By way of review, we need to focus on this question because it's the context for everything we're doing in this series. What is AI? My perspective is AI, first of all, consists of human attempts to fashion intelligent entities. For us today, those entities are computer systems. So, of course, we'd want autonomous computers, and autonomous means they can work, run, execute by themselves. Autonomous computers acting with plan and purpose. Those are two key characteristics of intelligence. A final way of thinking about AI is computers performing actions that require intelligence to do. What is an algorithm? Algorithms power computer systems. And yeah, I know you've heard the term. Up before AI was a big term that overran everything else with computer science. Algorithm was a buzzword in the early part of the 2020s. Everybody knew about the algorithm controlling whatever it might be. So, what is an algorithm? Here's the definition that I'm going to work with in this series. An algorithm is defined as a detailed, unambiguous, and effective set of step-by-step procedures for solving a problem. If you already knew that algorithms had something to do with solving problems, you're exactly right. Now, notice I've got three qualifiers there: detailed, unambiguous, and effective. We're going to look a little in depth at what those are. So you're saying, that's a horrible. Well, tell me what an algorithm is. Algorithms are instructions. Here's the problem with making the definition too simple, though. Because when I say algorithms are instructions, then people come up with a wrong-headed idea of what they're really all about. Algorithms are like instructions. All right, don't worry. We're going to investigate exactly what this means. But let me read to you a little description. In the opening video of this series, we took a look at ChatGPT, and we'll continue to investigate that as a current example in the 2020s of artificial intelligence. Let me read you this little definition of what ChatGPT is. ChatGPT is a chatbot that can not only engage in human-like conversation, but also provide accurate answers to questions in a wide range of knowledge domains. The chatbot, created by the firm OpenAI, is based on a family of large language models, algorithms that can recognize, predict, and generate text based on patterns they identify in datasets containing hundreds of millions of words. We saw large language model briefly before as an aspect of AI, and we'll see it again. But notice this definition says ChatGPT uses a large language model, which is an algorithm that can recognize, predict, and generate text. Before we see algorithms in the context of AI, let's take a look at algorithms in the context we're all used to, and that's apps. App is really short for application package. I'm probably the only person that says application package. A set of software instructions or algorithms that solve specific user problems. You use many different apps all the time on a computer, on a mobile device, whatever. We use apps all the time. So, what is an app? An app, by definition, is a collection of many effective algorithms written in a programming language. One app is a collection of many algorithms. One way to imagine it is consider any app that you use. Let's consider word processing. Consider any word processor that you use, maybe Microsoft Office Word or maybe Pages on a Mac or something similar. Word processors, have hundreds of features. They could do lots of different things. Every feature or function in your word processor is powered by an algorithm. Spell check, that's an algorithm. Saving a file, that's an algorithm. Italicizing a word in your document, that's an algorithm. Changing the size and style of your fonts, that's an algorithm. Find and replace, that's an algorithm. And the list goes on. So algorithms are just those set of instructions that allow our apps to do what the apps can do. A word processor is designed to allow users to enter, edit, format, access, and distribute documentation. So all the algorithms that allow it to do that. Now, earlier I said if we just call an algorithm an instruction, we're going to miss something. Although you'll oftentimes hear people say, oh, algorithms are really simple. They're sort of like this. Algorithms are not like instructions. The instructions that you get in the box of that fine furniture that you picked up and had to assemble, those instructions on how to assemble a bookcase, that is not an algorithm. Oh, speaking of instructions, you heard this news story recently that the CEO of IKEA, IKEA makes all that fine furniture that you get to assemble, was recently elected the president of Sweden. Yeah. When asked, what are you going to do next? He said, I'll be assembling my cabinet. I'll be a. We're going to see that algorithms are not like human instructions. Neither are they like directions. If you ask somebody, how do I get to Trump Tower in downtown Chicago? Well, you might get accurate directions or you might not, right? Algorithms are not like directions on how to get somewhere. Algorithms are not like recipes. How to make angel food cake. If you're not an accomplished baker, when you read that recipe, you're really not going to know what to do, right? Algorithms are not like plans. I'm sure that you make plans. I've made lots of plans. I plan out my vacations. I plan them out months ahead of time. And you know what? Something almost always forces me to change those plans. Algorithms are not like human instructions, directions, recipes, or plans. Why not? See, algorithms have to be perfect. Are plans perfect? When I was an undergraduate student, every semester I made a plan. Okay, I got to take these classes and get this grade and yeah, uh-huh. No, plans are always changing. Our plans are not perfect. On the other hand, An algorithm would be like God's plans because God's plans are perfect. God speaking through the prophet Jeremiah. For I know the plans I have for you, declares the Lord. Plans to prosper you and not to harm you. Plans to give you hope and a future. Jeremiah 29, verse 11. God gave the people hope, this perfect plan, through the prophet. Now, the people of Israel couldn't quite see this perfect plan. If you know the context, they were slaves in a foreign country when the prophet was giving them this, but the plan was still there, and God carried out his plan. Let me show you a little bit more about algorithms, how they're not like human instructions. Unlike human instructions, make instructions, algorithms must be detailed. And by detailed, I mean an algorithm must list every step. When you're following a set of instructions, if you know what you're doing or apply your intelligence, even if the step is left out, you can overcome that. You can still carry on. Not a computer. Algorithms must list every step. May I give you an example? You know what Post-it notes are? I have in my collection a very valuable, at least to me, set of old Post-it notes from the early 90s. Post-it notes were created in the 1980s by 3M Corporation, very ubiquitous today. And the reason I like this particular package that I have of Post-it notes is because on the back, there are instructions. The instructions are not how to use the Post-it notes. The instructions are actually on how to open the package. The Post-it notes are wrapped in cellophane. You wonder, how do I open it? Ah, you read the back of the package. It says, hold pad in both hands and twist. Peel off wrapper. I'm twisting. Nothing's happening. Of course, the instructions meant twist your hands, in which case you would break the cellophane wrapping. You see the problem? It didn't state twist your hands. While we could understand it, a computer could not follow it. It's not an algorithm. Algorithms must be detailed. Secondly, algorithms are not like human instructions because algorithms must be unambiguous. Sorry, that's a horrible word. Ambiguous means confused, cloudy, unclear, like this one-way sign. Algorithms must be unambiguous. And by that we mean crystal clear. Every step must be totally understandable, crystal clear. Let me illustrate this. Many of you probably don't know this. Do you know there are instructions on the back of your shampoo bottle? There really are. I like the little shampoo bottle that I have here and I use as a reference because on the back there are 4 steps. Seems pretty detailed, right? Here are those steps. Apply to wet hair. Work up rich lather. Rinse. Repeat. Pretty detailed. There's a problem. We could find a problem with any of those steps, but I'm going to focus on step 4, which said repeat. We know if we're washing our hair, by the way, if you're like me, you think they just put repeat in there to make you use more shampoo? We know if we read that, we mean do it one more time if we feel like it. Ah, but what does repeat mean? It means go back and do it again. So if we applied this shampoo out, how long would a computer spend washing its hair? That's right. Every time we got to step 4, back to 1. Apply to wet hair, work up rich lather, rinse, repeat, 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 repeat. Those instructions were ambiguous. So algorithms are special, different, unique. For example, if you take a look in the book of Genesis, in Genesis chapter 6, you'll see God telling Noah, his sons, and likely the workers that Noah employed, how to build the ark. Is God giving them an algorithm? Let's look at it. Make yourself an ark, specify the type of wood, rooms, cover the wood inside and out with pitch. Oh, look, pretty specific length, width, and height. Make a roof, finish it to within 18 inches of the roof. Set a door on the side, lower, second, and third decks. Is that an algorithm? No. Computer scientists would call this requirements, what's needed to solve the problem. But it's certainly, I couldn't build an ark based upon that. If you've been to the Answers in Genesis life-size replica of the ark in Kentucky, you could imagine the blueprints and the detail that went into constructing that ark. Not an algorithm. In a computer system, algorithms come in two basic kinds: arithmetic algorithms and logical algorithms. That is, algorithms that employ arithmetic operations, add, subtract, multiply, divide, and others, and algorithms that employ logical operations. A logical operation is a comparison, comparing one value to the other. Is it greater than? Is it less than? Is it equal to? This is why computers give the appearance of being intelligent, because not only can they do arithmetic operations much faster than we can, I could ask a computer system to compute the first 1,000 prime numbers. You recall that a prime number is a number that's only evenly divisible by 1 and itself. 1, 2, well, 1 is technically not a prime. Okay. 1, 2, 3, 5, 7. 9 isn't, because it's evenly divisible by 3, and so it goes. A computer can compute the first 1,000 prime numbers in a tiny fraction of a second. Whew, it would take me a long time to try to figure that out. By the way, if you think this is just a silly example, prime numbers are very important in cryptography. Prime numbers are used for security. When you send information online today, cryptography is used to help ensure that it's safe and secure, and prime numbers are the foundation of the algorithm dealing with that. By the way, how would an intelligent farmer count his cattle? Oh, he'd use a calculator. Logical operations, though, are really what gives the computer the appearance of intelligence. And we see this all the time. Use a word processor? Do you use spell check? For some reason, when I put Jesus' words on the cross from Mark 15 into my word processor, it didn't understand Aramaic. Jesus actually spoke in Galilean Aramaic. The ninth hour, Jesus cried out with a loud voice. How come the computer thought that those were misspelled? It used logical operations to compare my words, my data in English to a standard dictionary file of correctly spelled words. And Eloi, Eloi, lema sabachthani are not English words. So it flagged them as being misspelled. Ah. In other words, the computer uses logical operations to make a comparison to determine if the word is spelled correctly or not. Logical operations are powerful. Yes, computers absolutely appear intelligent. Computers can perform operations in tiny fractions of a second. If I wanted to purchase this car, a 2019 ZR1 Corvette, for a mere $125,000, and I wonder, can I afford that? I don't have $125,000 lying around. So I know that I can borrow the money for 4 years at 5% interest. So I put it into the computer system and it tells me instantaneously your payments are $2,935 a month. That's arithmetic processing. And then it uses logical operations to compare what fraction of my monthly income that would be and see if it would be reasonable for me to afford that. Since that's more than I earn in a month, okay, maybe not. But still, since it's such a large fraction of what I earn in a month, the computer system says, ooh, sorry, you really can't afford that. Now, we would expect this. Human beings are created in God's image. And one of the birthday gifts the Creator gave both Adam and Eve and us is intelligence. We're not omnipotent, we're not intelligent like God, but we do have a small scale. We do have a small scale of intelligence being human beings. We would expect that. Just as human beings are intelligent because we were created by an omnipotent God, our devices, our computers, the tools that we create to help ourselves, they should reflect some of our intelligence also. Sometimes I heard people say, nah, computers only do what they're told to do. That's interesting. We're going to investigate that today. That's not entirely true, as we'll see. Don't confuse answer with algorithm. Sometimes people think computers only do what they're told to do means we already know the answer. We certainly don't know the answer. We certainly have to know the algorithm, how to determine the answer. But what if I told the computer to learn something new? Or what if I told the computer to predict the future? Can AI learn? Can AI predict? The answer is yes. So if you believe computers only do what they're told to do, you really have to broaden your horizon because I'm going to tell the computer to learn. I'm going to tell the computer to predict something that did not exist before. Artificial intelligence is technology doing what humans would need intelligence to accomplish. Absolutely. You should know that at work, my boss calls me the computer. Has nothing to do with my intelligence. It's just the fact that I'm left alone for 15 minutes, I'll fall asleep. Let's consider how artificial intelligence might be used in a retail business, in e-commerce. Whether you go to a brick and mortar store or you shop online, how can AI be used in e-commerce? E-commerce platforms use AI for personalized marketing and dynamic pricing. If you go to a site like Amazon, have you noticed not only do you get recommendations all the time, hey, you should buy this too, but if you look at an item and you look at that item every couple of days, you'll notice the price changes constantly, doesn't it? So, recommendations. Recommendation systems are AI-powered systems that suggest products for sale based on customer behavior. Dynamic pricing. AI systems are saying, okay, hey, do I need to lower the price a little bit to increase sales? Or Can I increase the price a little bit and make it look scarce? Or for whatever reason, it changes the pricing all the time. AI is used in e-commerce to predict inventory. Stores don't want to have a lot in inventory. The Dollar General store doesn't want a lot in inventory there. Amazon has huge warehouses, but still, they don't want to have a lot of stuff hanging around in inventory. Folks in the trade call this JIT, just in time. You want to have those stuff come into the warehouse, not stay very long, and be shipped out to customers. E-commerce sites use chatbots for customer service. When you say, I need help, you're not initially talking to a human being. You may never talk to a human being. You're talking to an AI-powered chatbot. And if you're a large organization like Walmart or Amazon, their huge warehouses are run by AI-powered robots that will pick the items that are needed, put them in the box, and send them on to shipping. Now, of course, all of this could be done by people, but we'd be slow. We couldn't deal with the enormous amount of data that's happening here. Let's take a look in a little depth at how AI can learn. AI can learn using something called ML, machine learning algorithms. I'm going to give you an example of one. Most people believe there are three general machine learning algorithms. We're going to investigate, first of all, something called regression analysis. Regression analysis. But what is machine learning all about? Machine learning is all about getting the computer to act without specific programming. I'm not going to tell the computer what to do. Getting computers to act without being explicitly programmed. In other words, AI is going to allow the computer to acquire behaviors without people overtly programming it. By behaviors, I mean acting, doing something, recommending this particular product. In other words, we're going to teach a computer to learn concepts from data. So programmers are not telling the computer what to do. Instead, a computer learns what to do. In essence, we're going to give the system intelligence to learn how to solve the problem. Computer scientists give AI systems the intelligence to find and detect patterns in large, enormously large data sets. AI can learn. Computers can learn without being explicitly programmed. So, back to our simple machine learning algorithm, something called regression analysis. Let me set up a scenario for you. Could artificial intelligence be used to predict exam scores of students based on the number of hours that they work? Well, let's just say, I'll show you a data set here. This is not true. I didn't want to use any real data set. But let's say that I queried students. I asked, how many hours did you spend studying for this exam? And then I looked up what grade they earned. So I listed this all here. Okay. Let me show it to you in a chart, in a graph. Oh, excuse me. I got to get a system to work correctly. Here's that same data in a graphic form, in tabular form. And it looks just like random stuff. There's dots all over the place. However, we can use an algorithm. I'm first of all going to use an algorithm called linear regression. And this linear regression is going to try to figure out When a new student comes in and says, okay, I studied for 4.3 hours, what kind of grade might they earn? The system is going to use regression analysis. This is a linear, a line. Going to put a line through it. You can see it's not precise, but it might be a fairly good predictor. The pattern was then analyzed in order to make future predictions. If you study for X hours, what exam score might you get? Now, this prediction could improve in two ways. Number one, adding more data. And number two, maybe the best way to analyze is not with a straight line, but with a curve, a polynomial. Okay. Regression analysis. Here's one way that a computer system can make a prediction. I didn't tell it how to do that. It analyzed the data and it said, I'm going to choose this. And then when a new user comes along and says, I studied for 6.3 hours, it will say, okay, this is a score you're going to earn, 68. How does the system learn? Truly. Regression is not the only machine learning model. Machine learning algorithms include not only regression analysis, linear polynomial analysis, etc., but also decision trees and neural networks. We'll investigate both of those and more neural networks later. Learning new behaviors, what's that mean? Results from changing the learning model, changing the algorithm. Learning happens when the neural network changes based upon more data over time. So the more data it gets, the more prediction it makes, the better it becomes. Learning new behaviors results from changes the learning algorithm makes to the internal representation of the model. Sometimes we call this the reasoning model, the neural network, the decision tree, or the regression. Large amounts of training data are required to make the model better. The more data, the better, we think, the model becomes. Artificial intelligence certainly does learn in this sense. I suppose later we should ask the question, is this learning in the same way that people do? Well, in a focused, narrow way, maybe. How should we approach AI? I'm going to suggest with hopeful hesitation. I don't want to jump in. I don't want to be all in with AI. I want to approach it with some hope, but I also want to be hesitant. Hopefully, no pun intended, what I've shared with you today is now you see, okay, what AI is doing is based upon some algorithms that smart, intelligent people created. But once we've sort of given it the framework for how to learn, now the system can take that framework, apply it to data, and make some decisions. What product would you like? Or what score might you earn on the next test? But it's very important that when we approach any type of AI, we understand not only the tech, but also its designers and their worldview. Whether or not they're approaching AI from a Christian worldview is very important. What we're going to do as just users of AI is use our God-given abilities, that's our rational mind and our discerning soul, to stop and evaluate what's happening here. We got to get beyond the hype. We got to think about this. God has given us the abilities to discern what is true good, and beautiful. And we should apply that everywhere, and especially in the world of artificial intelligence. This is Daniel approaching King Nebuchadnezzar. You can read about it in Daniel 1. Just before the verses I'm going to share with you, something interesting happened. Daniel was one of the princes of Israel that came to Babylonia, and they wanted him to eat all the same food the other ones did. And Daniel said no. Reason why is he'd be defiling himself. Was it food offered to idols? Didn't know. So he asked, give us plain vegetables and water, please. But then he proposed a scientific test. He said, don't take our word for it. Do a 10-day trial and then compare us, both our appearance and our strength, to the others and see which is better. And there was no doubt. Daniel and his friends were better. But then comes this from Daniel 1. As for these 4 youths, Daniel and his friends, Shadrach, Meshach, Abednego, God gave them learning and skill in all literature and wisdom. And Daniel had understanding in all visions and dreams. The king spoke with them, and among all them none was found like Daniel, Hananiah, Mishael, and Azariah. And in every matter of wisdom and understanding about which the king inquired of them, he found them 10 times better than all the magicians and enchanters that were in all his kingdom. God grants intelligence. Having a worldview that connects you to the true triune God will give you better insight and better understanding. And hopefully you'll be able to understand AI even better. Thank you so much again for joining me today. What are your thoughts about AI? What are your questions about AI? How could I have improved this discussion of artificial intelligence? One thing you're saying is, well, you needed more jokes. I mean, doesn't Noah lend himself to, oh, sure. Yeah, I could have told lots of jokes about Noah. How did Noah see at night on the ark? Flood lights. You know who Noah's wife was, right? Mrs. Noah? You don't know her name? Her name was Joan. Joan of Arc. Oh, see, maybe more jokes would not improve what we're doing here. But please leave your comments for me. Contact me and let me know what you think and how I could improve this. But until we meet again, Psalm 19, the heavens declare the glory of God. It's obvious to anyone who looks at creation. The sky above proclaims his handiwork. Day to day pours out speech, and night to night reveals knowledge. The law of the Lord is perfect, reviving the soul. The testimony of the Lord is sure, making wise the simple. The precepts of the Lord are right, rejoicing the heart. The commandment of the Lord is pure, enlightening the eyes. Thank you so much for your rapt attention. I appreciate it. Until we meet again, may God hold you in the palm of his hand. Blessings, everyone. Take care.